Do you have wisdom teeth? If you never grew them, the question is, does it mean you are more evolved than people who did? Biologist Dominic Geraghty and physicist Denis Visentin are with us from UTAS. Hello, how are you both?
Very well.
Very well, thank you.
Who wants this question?
I'll try it.
The biologist puts his hand up. What is it, Dom?
Neither really, because it's purely genetic. From what we can gather, it's associated with I think it's called PAX3 or PAX4 gene, and basically some people, some ethnic groups have got no wisdom teeth and never do have. For example, Tasmanian Aboriginals do not have wisdom teeth. I'm reliably informed. Whereas Indigenous Mexicans, all of them will get wisdom teeth. And the second question you're going to ask, I hope, is should they be removed? And the Cochrane libraries, the Cochrane studies, have actually shown that they don't know whether they should or not. Typical scientific answer. You know, they're not sure whether we should be removing them or not removing them, except for the fact that periodontitis, in other words, basically sick gums, occurs if you leave them in and they become impacted. But so it's really, we don't know.
Do we know if we need them?
Some of the anthropological studies and archaeological studies of ancient skulls have shown that the mostly older civilizations had them because they needed them for grinding plant matter. But as we have evolved, and the comment was that as we evolve, that we shouldn't need them because we don't grind, that we should really be grinding a lot more plant matter than we do currently. So really it's purely genetic. Whether what's called epigenetics has affected the evolution of our teeth, we don't know yet.
I guess if you think about evolution and my limited knowledge, you're not going to not survive if you do have them. No. So you're not going to die off.
We've got lots of bits and pieces in our body. For example, our appendix apparently we don't need, but so there's lots of sort of vestigial. We call it vestigial, and the wisdom teeth are definitely what's called vestigial. We don't really need them.
You can get your questions answered today, 1300 222 936, 1300 222 936, or you can text it in on 0438 922 936, like Emma has. Hi Penny, science question. How old is the gold in my wedding ring? When was it geologically formed? Millions of years ago, or is gold still forming now? I'm going to go to you, Dennis.
No, well, some gold is forming by some processes, but actually the gold on the Earth, it wasn't geologically formed at all. It was formed in a supernova. And in fact, there are all the elements that are heavier than iron have been formed by supernova processes. So a supernova is what happens when a star dies.
Thank you. I was going to say, I know the song Champagne Supernova, Oasis, but what is a supernova?
So there are two types of stars called Type 1 and Type 2. Some of the stars that are in the universe are the original stars that were formed out of hydrogen and helium gas, and some of them are secondary stars that have been created out of the leftovers from other stars. Our sun is one of those stars that has been created out of the leftovers, and we know this because it's got elements in it, or in our solar system, that are heavier than iron, so gold and uranium and all these types of things can't be made in the nuclear processes in stars. They can only be made in this incredibly strong pressures that are produced when the stars die, when a supernova happens.
So to answer that, it's not still forming?
No, it's stardust.
It's stardust.
So all of that,
so much more romantic when you're proposing?
I, in fact, wrote a poem about it.
Really?
and curated an exhibition called Stardust.
That's fantastic. And so, if you propose with a ring made from stardust, it's gorgeous.
It's lovely.
Sounds a little better, doesn't it? Yeah, I like that.
Okay. Another question for you from Douglas. Why isn't water highly inflammable?
It sounds like a double negative to me, which has confused me.
Why isn't water highly inflammable? Is water highly inflammable?
No.
No.
No. It's very non-flammable.
It's very non-flammable.
But why isn't it? Because it's got oxygen and hydrogen in it, but because the oxygen and the hydrogen are chemically bonded to each other, on that basis it becomes non-flammable. But if you can split water, you develop hydrogen, and of course you will end up having something, and oxygen, which will make something that goes bang very quickly.
There you go. There's the answer, Douglas. Paul says, if nothing sticks to Teflon, what sticks Teflon to a frying pan?
a lock and key mechanism. So on the one side of the Teflon, they actually put like a structure made out of the Teflon that's actually
You're doing
like
hand
yes, I
movements
am.
for that structure. Yeah.
So yeah, it's not going to stick. You can't make it adhere to the other surface. So you do need to have. It's got to have hooks basically.
So you've got a structure where one side's Teflon and one side isn't.
No, one side of it will be Teflon, but smooth Teflon, and the other side will be Teflon with some sort of hook structures on it, so that you can actually make it bond to the other material.
How do you get the hooks into the Teflon?
That's a question for another day, and another person, hopefully.
I'm sure you can find the answer on the internet.
But that Teflon's a really good example of a spin-off. Spin-off technology out of pure science. Teflon was created or discovered out of the space program. So, it was actually a big resource that came out of just pure funding of the space program.
What were they trying to find or discover?
I have no idea.
Same as mobile phones came out of space travel.
Okay,
They
explain.
developed all of that. Well, basically, they needed some mechanism which was wireless to communicate across time, across space, very, very quickly. And so they invented mobile phone technology.
Yeah,
to
a
do
lot of the real-time computing as well was designed to support the space program, which apparently has come in handy.
Apparently. How many are there in this room at the moment? When you talk about, you said space travel, but you accidentally said time travel. Another question that came up, I think it was last week, and you've just reminded me of it, or last time you were in, is time travel possible? How long have you got? Is it a couple of hours to answer this
Sounds like
question?
a question for a physicist. Yes, time travel appears to be possible by a couple of different methods. One method would be if you can travel faster than the speed of light, you can actually travel back in time. So being able to travel at called tachyonic speeds, speeds faster than the speed of light, will allow you to go back in time. Now, even if that's not possible, you can travel at sub-tachyonic speeds if you have a wormhole available to you. The best way to imagine a wormhole is think about travelling between 2 points, and the points are drawn on a piece of paper. So the shortest distance between those 2 points would be a straight line. Now, if you get the piece of paper and you bend it so that the 2 points are now very close together, and instead of going over the surface of the paper, you tunnel between the points, you can actually travel faster than light, say, can travel from one point to the other. And that would also provide you with a time travel mechanism. So this wormhole technique, it's often described in science fiction. Now, were such a thing to occur and is possible in general relativity, in Einstein's general relativity, that would allow you to travel back in time. And this can be achieved. Space-time can be bent in areas around very strong gravitational fields. So black holes would be a possible example of the generation of a wormhole.
That's not how Marty McFly did it at all. He had it, was it a DeLorean? DeLorean,
Yeah.
that's right.
Built in Ireland.
Oh,
Built
really?
in Northern Ireland, yes. The DeLorean sports car. Apparently there was orders went in for about 3,000 of them when they said they were closing the factory. So.
Well, and I think the one went not too long ago for an extraordinary price. Anyway, he's going back years and years, though. I mean, that's when we talk about time travel. People want to go back years and years. With the wormhole that you're talking about, it's only a few seconds, is it?
It would depend on the size of the bend.
Okay.
So if we can imagine the whole universe was bent backwards on itself, you could travel across the whole universe, in a few seconds, and that would allow you to travel back in time, perhaps to the Big Bang.
Perhaps.
So you could travel at any, depending on how the wormhole is constructed, will determine how far you can go back in time.
Where would you go?
I'd probably stay where I am. I'm having a great time.
Yeah, me too. I like where I am. It's a nice space.
With that in mind, can you travel forward?
Yes.
Same.
Yes, the same principle.
Okay. Another question that's come through. Why do we remember some dreams and not others?
Ooh, it depends on how close to consciousness you are when you actually have the dream. So we have 2 stages of sleep, effectively 2 stages. One is called REM, the other one is called non-REM. Now, REM is rapid eye movement sleep, so if you were to wake somebody or try to wake somebody when they're in REM sleep, it's quite difficult because it's actually the deepest stage of sleep, although paradoxically it appears as if the person is close to consciousness. So a REM dream, and maybe somebody may correct me if I'm wrong, if you have a dream when you're in REM, it's unlikely that you will remember it because it's very, very deep inside that unconscious state, whereas if you towards the area where you're coming in out of unconsciousnness into wakefulness, then you will most likely remember that dream.
Why do we dream?
Good question. There's a lot of sort of theories put around, but it's a way for which the brain can dispense of some of the traumas that occur during everyday life, and that we mix them up because, let's face it, sometimes you have some really bizarre dreams.
You walk into one building, but then when you walk outside, it's a different place altogether, or whatever it might be.
You've been looking at far too many sci-fi movies. There was one with Leonardo DiCaprio where they were getting inside people's dreams. I thought that was actually quite groovy.
Inception?
Inception,
No?
yeah. Inception was fantastic. So that's basically it. It's just why we dream, probably to the brain just trying to get rid of some of the garbage of the day.
1300 222 936. If you've got a question for these guys, Dominic and Denis, 1300 222 936. But I understand they come armed with a number of bits of information when they walk into the studio, including some trivia about Monty Python.
Yeah,
What's happening?
It must be about 30-odd years ago, or if not more, probably 40 years ago, that the Monty Python crew came up with the Universe song. And in keeping with a lot of the stuff that Monty Python did, a lot of the mathematics behind it was actually correct. So the Earth spinning at a certain speed and the speed of light and so on. But they now realise that some of the content of that song was incorrect. So many of you will have heard of Professor Brian Cox, who's doing all of these programmes. He's the new golden boy of science on TV, is getting back together with the Monty Python team to rewrite the Universe song so that it is now accurate and up to today's standards of physics.
It was for the movie Meaning of Life.
Yeah, from the Meaning of Life, yeah.
And who will then, in 30 or 60 years' time, update it again?
Who knows? But what's really lovely about science is that this concept of science being still or being it's only ever a fixed point in time. The classic questions I often talk to first year students when I ask them, say, how much of your brain do you use? And they always come out with 1%. And I go, where did you hear that? Oh, I don't know. I just heard it somewhere. So somebody said it at some stage and that becomes fact, when in fact it's total rubbish.
How much do we use? I heard it was an eighth.
Well, there you go, you see. So where did you hear that?
I don't know. There's that movie Phenomenon. It always comes back to movies. It's got what's
You're just
his
a
name
John Travolting.
John Travolta.
John Travolta actually only uses 1% of his brain. That's true.
Okay. But do we know how much we use?
No. Mm-hmm. And we talked about evolution earlier on. We are constantly evolving, and we were talking about rewiring your brain. So, for example, the program with Todd Sampson on television recently, the idea is that we can actually change the way in which our brain functions by doing things in a different way. So,
my guess is you use quite a lot of it. There was an experiment done on the use of the brain, what parts of the brain were being used for which fingers. And they looked at a monkey and they actually cut the finger off a monkey. It's just a terrible experiment to perform. And what they saw was that the parts of the brain that looked after each finger actually grew to take over the part that was looking after the preceding finger. Now, what that suggests to me is that we're not, brain space is actually quite a useful resource and we don't waste a lot of it. Now, we might not be using all of the bits of our brains all the time, but it's not like there are big chunks of our brain that are not going to be for anything. So all of our brain is certainly for something, and we might not necessarily use it all the time. But
there's a lot of reserve in the tank. There was a fantastic situation many years ago where a girl had significant epileptic seizures and one side of her brain was basically non-functional, so they removed it. And she was left with some deficits, but really she'd been using the other side of her brain for so long that she really, and I'm going to use this very loosely, didn't require the other bit of a brain. So they actually took it out. They actually took out half her brain.
Fascinating stuff. Bill's called through from Deloraine. Hi, Bill.
Hi there.
What's your question?
Well, I'm wondering, once a black hole can't eat any more of its surroundings because it's too far away, and it's starting to lose matter and energy through Hawking radiation, will it eventually burst back to life as a star? when it can no longer sustain itself.
Can you bear with me for a minute there, Bill? We've just got a problem with our headphones here. Just a second, we'll be back with you in a moment. Sorry about that, Bill. We'll just get you to ask your question again. Go for it.
Okay, I've got a question about black holes. I'm thinking when they can't get any bigger because they've consumed all their surroundings and they're starting to lose matter and energy through Hawking radiation, will they eventually burst back to life as a star when they can no longer maintain themselves as a black hole?
Fantastic question. My headphones were actually working perfectly well. I was just stalling for time. Hawking radiation is really, really interesting. Just to explain that first, there are everywhere in the universe there are always particles being created, and we'll get these particle pairs created. So we'll get, say, 2 photons being created out of nothing, out of the vacuum. So these virtual particles are always being created. But if we can imagine at what's called the event horizon of the black hole, if you create 2 photons at the surface, then one of the photons will go into the black hole and never to come out again, and the other one can travel away and actually take energy away from the black hole. So this Hawking radiation is actually a process by which the energy of the black hole can actually escape. It's quite an astounding discovery, actually. It wouldn't go back to being a star, but it would actually, the black hole itself would disappear with time. So the Hawking radiation, because it's carrying matter and energy away from the black hole, eventually the black hole would evaporate, I guess, by this Hawking process. But that doesn't leave you with a star. It actually leaves you with, I'd hesitate to say the word nothing, but it takes away the black hole. The only thing that would be left is what's called a singularity, and an evaporated black hole. We think what would be left is what's called a naked singularity.
Can we talk about that on the public radio?
I think we can. Well, a singularity is actually where the laws of physics break down. And we don't really know what would happen in the singularity. But now, usually they're nicely covered by a black hole that prevents us from observing them. But if the black hole had actually evaporated away, we're left with this naked singularity, which could do anything.
Ooh.
So that would be an incredibly interesting thing to observe.
We can only postulate, we can't really observe.
Yes, well, if we observed something very, very strange happening in the universe that we hadn't observed before, then we can, perhaps put that down to a singularity, I guess. I agree with you that we wouldn't know what we would be looking at, but perhaps it would have some properties that would be quite strange. So, yes, I'd be pretty keen to see one.
There you go, Bill. Answer your question.
Thanks very much.
Good on you. See you later. Colin's called through from Lewisham. Hi, Colin.
Hi.
What's your question?
The question is, this giant vacuum cleaner called Venus, if it wasn't there, how would Earth survive?
I guess you're talking about asteroids.
Yes.
Yes, we would probably have a few more difficulties. I mean, one of the things that makes the Earth habitable is not just. I mean, it's called we're in the Goldilocks zone, where it's not too cold and not too hot, and allows us to have an atmosphere and all those sorts of things. So there's lots of things about the Earth that make it habitable for life. But one thing that you also need is that it's not getting pounded by cataclysmic asteroids, every other week. It's certainly happened a few times in the past, but certainly life wouldn't have happened on Earth if we were continually being pounded by asteroids. So if Venus wasn't there, it would mean that more asteroids would certainly have been hitting Earth and might have meant that life wouldn't have A, started or B, continued on Earth. So, yeah, I'm glad it's there.
I'm glad it's there. Good on you. Thanks,
It looks
Colin.
pretty in the sky as well. So,
See you later. That's Colin in Lewisham. Mark from Scottsdale's called through with a question, and I think this comes back to you, Dominic. How do you know when your brain memory is full? Do you know when your brain memories, can it get full?
Normally after a meeting that goes for about 4 hours. Any meeting that goes for 4 hours, your brain is full. That's an imponderable, really, because different people have different capacities for memory. I think
Is that learned? Your capacity for memory?
You can train your memory very, very efficiently by doing things in particular ways, by word association. I mean, again, if you go back to that program, memorising a deck of cards, you can train yourself to do that. You can train yourself to do most things. And it is so, some people's memories, let's talk about John Travolta again, that would be... Sorry, John. So the idea here is that it's just simply a case of working, and also working memory, by the way. So we talk about short-term memory and long-term memory and what's called memory consolidation. So, for example, how many landline telephone numbers have you had in your life?
Yeah, a few.
A few. Can you remember the first, second, third, fourth, or fifth
and
one?
most of the ones from my friends when I was at school. But I can't remember their mobile number.
Well, see, my wife can memorise multiple mobile phone numbers, and I find that really quite amazing because I don't require to remember them because I've got a phone where I can dial it. So therefore, the idea here is to talk about memory consolidation. But you need to put... for example, Alzheimer's, one of the biggest scourges of our lives now because of the ageing population, is the fact that people can often remember things in the distant past, but they can't remember things that are just happening 10 seconds ago. That is, they're not able to transfer information from short-term memory into long-term memory. Now, I'll ask a bunch of students. It's exam time at the university at the moment. We're the most hated people on earth, probably, are we? Yeah. And the idea there is that students will be cramming large amounts of information, possibly, into a very, very short period of time. And it'll be a little bit like having a bad meal. You just gobble it all up and then get rid of it later on. It's the same concept with this information. They may not consolidate that memory because they haven't used it in their what's called working memory space. So, in answer to your question, and I'm going to give a typical Denis answer, it's a bit of both. You don't really know when it's full because it depends on how much you actually really want to put in there and how well you consolidate that memory.
Okay.
Very complicated.
It sounded fairly good to me. A question that led on from what I perhaps should have asked you before when we were talking about time travel. On the text, if you travelled back to the Big Bang, would you still exist? Work that out.
You'd probably die instantly, which would be a minor drawback of the trip. But perhaps the question is asking about what would happen to yourself that's in the current time. I mean, you have all these sort of grandmother paradoxes that you go back in time and kill your grandmother. Why people hate their grandmothers so much, I've never worked out. But
Marty McFly nearly went out with his mother. That was the problem.
Well, actually, one reason for the non-existence of time travel that's being proposed is because these paradoxes exist. So some physicists and philosophers have stated or have proposed that one of the reasons you can't travel through time, or one reason we might never be able to travel through time, is because these paradoxes existed. And so there has to be some rule against time travel that we haven't learnt yet, or we haven't understood yet, in order to overcome these paradoxes.